Yeah, good everyone. How are you all doing? So today we will be talking about the urea cycle and how are you going to understand your urea cycle? Very simple in a easy peasy way. Okay, now let's start by introducing ourselves to what is urea itself. In our last video, we explained what urea is. What is the last video about the amino acid, how to draw the structure of the amino acids. So, what is urea? We said urea is a compound that has two nitrogen and one what carbon. It has what two nitrogen and a single carbon. That is a nitrogen here, a carbon, then a nitrogen. Okay, it has two nitrogen and one carbon. And what type of carbon? It is a carbonyl carbon, that is a carbon with oxygen on it like this. Do you understand this? Just two nitrogen and one carbon, and that carbon is carrying what oxygen. And this nitrogen, don't forget that what your nitrogen should have how many bonds around it? Three bonds. Now your nitrogen has one bond around this carbon here. This nitrogen also has one bond around this carbon. Are we together? So this nitrogen is supposed to have how many bonds around it? Three bonds. So this is one bond already. So it means what? Two more bonds, which is what? The hydrogen, H2. The other hydrogen, this other nitrogen should take two hydrogens, okay? Which is what? H2. So this is the structure of your what? Urea. That is your urea has what? Two nitrogen, that is two amino, one amino here, and the other amino with a carbon between them. I hope you understand that. So that should not be a problem for us. So we know what the urea is. Urea has two nitrogen and one carbon, and that carbon has an oxygen on it. So another thing you need to understand for you to understand your urea cycle in a easy peasy way. You already know what the structure of the urea is, right? So the next thing is you need to understand what is succinate, what is fumarate, what is malate. You need to understand the structure. And these structures are very what simple to understand, very simple to understand. Now, following this structure, when you understand these structures also, your urea cycle will be so easy for you. Okay. Now, what are these structures and how do you identify them? Very simple. Okay. Now, let's go. Don't forget the structure of your urea. Urea has how many nitrogen? Two nitrogens with one carbon between the two nitrogens. Okay. Now the next thing is I said you need to understand some four basic things. Okay. What are these four basic things? Now, these four things I said you need to understand the succinate, the fumarate, the malate, and the oxaloacetic. Okay. That's the oxaloacetate. These four guys you need to understand them. They are four, right? And they also have four carbons. There are four, right? Four substances, that four stuff, and each of them has what? Four carbon each. Each of them has four carbon. So this carbon, 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 carbon. For the first one, the other one also carbon, 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 carbon. For the third guy, carbon, 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 carbon. Is this slide showing? Now the next one, carbon, 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 carbon. So we have these four guys, and each of them has four carbons. Very easy to understand. Now the next one is that what? Each of them also has what? Carboxylic acid group. That is this carboxylic group. Each of them has the carboxylic group. Do you understand? Each of them has the carboxylic group. So we have carboxylic OOH, 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 carboxylic. But not just at the front only, both at the front and at the back. Do you understand it? They have carboxylic both at the front and at the back. OOH, OOH, carboxylic at the front, carboxylic at the back. OOH, OOH. I hope you understand this thing. So these are the four guys. You notice that what four of them look alike. Four carbons, carboxylic at the front, carboxylic at the back. Now the next thing is that what? How do we differentiate between these guys? You know, in our structure, you have hydrogen here, hydrogen here, hydrogen here, hydrogen here, blah blah blah. So now let's look at these guys. This one has nothing, only hydrogen, 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 hydrogen. But this guy has a double bond here. Okay, it means we will have one hydrogen here and one hydrogen here. What about this one? This one has an OH group here, just one OH group. The other one hydrogen, hydrogen, hydrogen. Okay, hydrogen, 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 hydrogen. What about this one? It has, okay, let me use this one for that, and let me put the last one at the back. So instead of giving this one OH, I should let me give this one the OH. Okay, it's still the same thing, okay, but let me give this one oxygen at the top. So it has oxygen. So one, two, three, four. Fine. So hydrogen, hydrogen, hydrogen. You complete your hydrogen, okay? Hydrogen and hydrogen. Now, how do you differentiate between these guys? You will notice that was this first guy here, between the two carbons, you know we have two carbons here. The first carbon and the last carbon has what? Carboxylic group, and that is what? The same for everything. Each of them, their first carbon and their last carbon has what? Carboxylic group. But they only differ in their what? Middle carbon. For this first one, it has nothing, ordinary hydrogen. For the second one, it has a double bond, right? For the third one, it has an oxygen on it. For the fourth one, it has an OH. So, what's the name of this guy? How do you identify this guy? Because this guy does not have anything. Because this first guy does not have anything. And when you don't have anything, what are you going to do? There is higher probability that what you are going to commit suicide because you don't have anything, right? You don't have anything, so there's higher probability that you are going to commit what? Suicide. So we call this guy what? Suiccinate. We call this first guy what? Suiccinate. I hope you understand it. This first guy is called what? Succinate, or you call it succinic acid. Okay, succinate. The second guy, you will notice that what? This second guy does not have anything also, but it has a double bond between the what? The carbons. It has a double bond between the carbon. So what do you call this guy? Don't forget your organic chemistry, your alkane and alkyne. And you know that when we have more double bonds, we get film when you burn it. Okay, so this one that has double bond is called what? Fumarate, from film. Fume, from film. When you have your double bond, you get a film, right? So you call it what? Fumarate. Fumarate. Do we understand it? Now, the next one is this guy. You notice that what? This guy, the only thing this guy also has is what? Oxygen. This guy has only what? Oxygen on it. So before cause of the oxygen, you will call it what? Oxaloacetate. Do you understand it? Oxalo. Because of the oxygen, call it what? Oxalo. Oxaloacetate. Do you understand it? The first guy does not have anything. So we call it what? Succinate, because it's gonna commit what? Suicide. Do you understand this thing? The other one is called what? Fumarate, because of this what? Double bond. This double bond is gonna cause what? Film when you burn it. Okay. What about the other guy that has oxygen? We call it what? Oxaloacetate. Are we together? The fourth one. The fourth one has what? OH. And don't forget that what? OH can be gotten from water. That is when you break down your water. Okay. H2O can be broken down into what? Hydrogen ion and hydroxyl ion. Are we together? Hydrogen ion and hydroxyl ion. So now, what is this fourth guy name? Actually, this fourth guy name is kind of tricky. Let me tell you the name. This fourth guy name is known as what? Malate. Malate. So how do we know that this guy is malate? Just a trick to remember this guy and to know how to draw its structure and its name. Because the only thing it has is what? Just OH, right? So, and we know that what? OH can actually be gotten from water. So we say the only thing that can actually make me late to a class is if there is no water. Do you understand it? Before I can go late to class, it means that what probably like there is no water in my what hostel. I don't have water to cook, I don't have water to bathe. So because of that, there is that probability of what going late to class. So that late in malate, you take it as what late. So what causes the late? Absence of what water. What causes the late is what water. So this guy that has OH is known as what malate. That is why do you come late to class? Water. Do you understand it? So we give this guy what OH. You will see the OH and this H, they form the water. Do you understand it? For the first guy, succinate, he does not have anything. So we call it succinate because he's gonna commit suicide because he doesn't have anything. The other guy, we call it fumarate because of the double bond. He doesn't have anything, but it has a what? A double bond. The double bond will cause what? Fume. For the third guy, we have oxygen on it, on one of the carbon, right? You can see the carbon, we have oxygen on it. So because of the oxygen, we call it like you saying oxalate, okay? So the third guy, we call it what? Malate. Why did you come late? Because of the water, so OH. Do you understand it? That is this OH here and the hydrogen. It forms what? OH and hydrogen will form what? Water. So that is that about that. You need to understand this structure. You can see. So I hope you understand this. So understand your succinate, the structure, because you are still going to need this in your Krebs cycle. In order for you to understand your Krebs cycle, you need to understand all the succinates, because in your Krebs cycle you are going to form succinates, fumarate, and the likes. So when you understand their structure, it will be what very easy for you. Do you understand it? So now let's move on to the next side. Now you understand succinate, fumarate, oxalo, and this thing, what is it called, and the malate. So the next thing you need to understand is the structure of your what? Your arginine. In our last video on the structure of ammonia, we actually explained, or should I even say we demystified how to draw the structure of your arginine and other structure of amino acids. So when you want, if you want to draw the structure, then okay, in order for the yoga cycle to actually be what be simple for you, you also need to understand the structure of your what arginine. The structure of your what arginine. You need to understand the structure. You need to know how you draw the structure of your what arginine. Are you with me? So how do we draw our structure of arginine? Don't forget in the video I said, if you want to draw your arginine, just remember the guy Kun Aguero. Kun what? Aguero. So we have Kun. So we have Aguero. So this age is for your what? Your arginine, okay? So you draw it using your cone. And don't forget that what we said, if you want to draw the structure of any amino acid, one of the first structure you are going to draw is the structure of what? Alanine. Before you can draw the structure of any amino acid, apart from glycine, other amino acid, when you want to draw their structure, each of them will surely have the structure of what? Alanine. It means that what? If I want to draw this arginine, I need to draw what? First, alanine. If I want to draw arginine, I need to draw what? Alanine. This is just the recap. Okay. How do we draw our arginine? Our alanine first. NH2, carbon, COOH. Please, in case you don't understand this, you can watch our video on how to draw the structure of amino acid in order for you to understand this very well. So we have an hydrogen here and CH3. This is alanine, right? You then add other things to it. In order to get the structure of any amino acid, the first thing you need to draw is what? Alanine, then add other things to it. Now, so this is our alanine. So now we want to draw arginine. And I said you should take this what? Kun. So this kun means that what? We are going to add three things to this what? We are going to add three things to this alanine structure. What are the three things? The three things must end with what? N. You can see that this cone actually ends with what? N. So that three things must end with N. You add one, you add the second one. Why the last one should end with what? N. The two guys are just what? Carbon, carbon. Why the last one is what? The N, which is nitrogen. Do you understand it? So I'm gonna add carbon the first guy, carbon the next guy, and nitrogen the last guy. So this is the cone. Do you understand it? Do you understand it? So we've do this. Now, the next thing you need to add to the structure of your arginine is what? Urea. Because from arginine, we get what? Urea. That is to tell you that what? We get our urea from what? Arginine. Urea can actually be gotten from what? Arginine. Are we together? Urea can be gotten from what? Arginine. Okay, urea can be gotten from arginine. And don't forget the structure of your urea. Don't forget that what? Your urea is what? Your urea has how many carbon? One carbon. How many nitrogen? Two nitrogen. The carbon is between this what? The two nitrogen. Okay, and the carbon is carrying an oxygen. So this is our urea. The structure of urea: nitrogen, carbon which is carrying oxygen, and another nitrogen. The bonds around the carbon is four. One, two, three, four. Nitrogen is also supposed to have how many carbon? How many bonds around it? Three bonds. So this one is having one. Add two hydrogen to it so that it will have three bonds. Add two hydrogen to it. So this is what? Urea. So now what are we doing now? What we are doing now is that what? This urea, you will just bring it and attach it here. The moment you attach this urea here, you've gotten the structure of your what? Arginine. The first thing is what? Draw your alanine, then put the cone. After the cone, you put the structure of your what? Urea. That is to tell you that what? From this arginine, we can actually what? Derive our what? Urea. Now, when you understand this now, by the time I will start the urea cycle, you will see that what? Oh, this thing is very simple. Because we are still going to, a part of the urea cycle, we are going to remove the urea from this arginine structure. Do you understand it? So now I'm gonna bring this guy here and I'm gonna attach it here. But mind you, for this guy to come here, the oxygen will go. Okay? So by the time it's coming, I will just have ordinary NH2 carbon, NH2. And the double bond that was there before would have shifted to one of the what? Nitrogen. Either this nitrogen or this one. Okay? Do you understand it? So I will then attach it here. So let me attach that urea here. So I have NH2 carbon, NH2 carbon, NH2. Don't forget this guy was this before. NH2 carbon, oxygen, NH2. But before we can add this guy here, we need to remove this oxygen. Okay? So when we remove this oxygen, this double bond here we shift to what? Either what? This NH2 or this NH2. You can put it there, either for this one or for the other one. Okay? So we can put it here or put it here. Okay? So it will now give me one bond here. So this is one bond now. So this is the structure of what? Of our arginine. But be careful. This carbon is supposed to have how many bonds around it? Four bonds. So it has how many? One, one, two, three, four. Sharp is complete. What about this nitrogen? How many bonds around it? Three bonds. One and two from what? Hydrogen, making three is complete. What about this nitrogen? It's supposed to have how many bonds? Three bonds. Okay, so we have one, two. Okay, and also two from what? Hydrogen, making four. It means that what? We need to remove one hydrogen so that it's gonna have what? How many bonds? Three bonds. So one bond from hydrogen and this double bond, making three bonds. So this is the structure of what? Arginine. This is the structure of what? Arginine. Are you with me? So arginine, in order to draw the structure of your arginine, you need alanine structure first, which is what? All ammonia amino acid we have. The next thing is what? The cone. That is two carbon, end it with what? Nitrogen. This end it with nitrogen. Then bring the urea structure without oxygen, attaches to it. So this is what? Arginine. So this whole structure is known as what? Arginine. So this is the structure of our arginine. Are you with me? But don't you think that if, let's assume this urea is not there, don't you think that what this guy is supposed to have a name? Don't forget I said that what your urea can be gotten from this arginine, right? You notice that what if I should remove this lower part, the one with this last guy that we added, if we should remove it and just add oxygen, we are going to get urea. That is to tell you that what we can get urea from arginine, right? We can get urea from arginine. Okay, that means that if we should remove this part, it will remain what from this nitrogen of Kun to the top. Don't you think that what this guy itself is supposed to have its own name? This guy is supposed to have its own what? Its own name. Do you understand it? That is, if I should remove this urea part that I added for it to be arginine, if I should remove the urea part, this guy is supposed to have its own name. And this guy is known as what? Ornithine. This guy is known as what? That is from here to here. Ornithine. That is to tell you that what? Ornithine stops at what? Kun, without adding the urea part. Adding the urea part to your ornithine will give you what? The structure of what? Arginine. Are we together? This side without adding the urea is the what? Ornithine. Adding your urea to ornithine will give us what? Arginine. I hope you understand it. I hope you understand it. So I think that is all you need to know for now. Yeah, that's all we need to know. Yeah, that is all we need to know. That is all. Now let's start this. Let us start the cycle. You know the structure of your urea, right? Urea. Yeah, I need to come again. Urea, two nitrogen and one carbon between them. How do you draw the structure of your arginine? All amino acid needs to start from what? Alanine. After the alanine, put the kun of a kun aguero, put the kun that is two carbon, end it with what? N. And after that, add your urea part to it. Do you understand it? Add your urea part to it. Do you understand it? So you've gotten the structure of your what? Arginine. So, but if you should remove that urea part at the bottom, okay, that guy is gonna have what? Another name, which is what? Or ornithine. Okay, which is what? Ornithine. Do you understand it? So that is that about that. Now let's move into the cycle. Okay, let's start the cycle. I said you can actually what? Get your urea from arginine. That is by removing the lower part of the arginine. And don't forget that what? After removing the lower part of the arginine, that last part that we added, the remaining part is known as what? Ornithine. The remaining part is known as what? Ornithine. Okay. Now, but one thing you need to understand is that what? Your urea will not just attach to your ornithine and form arginine, or no. It actually needs to start from what? Somewhere. Now, where does this cycle actually what start from? It started from, okay, we have CO2 reacting with what? Ammonia. Okay, this is one of the first thing. Your CO2 what needs to react with what? Ammonia. But mind you, don't forget that what? In your body, CO2 is not just there as a gas. Okay, it reacts with what? Water to form what? Bicarbonate. Don't forget it. It is always in form of HCO3 minus. How is this gotten? That is, we have H2O plus CO2. This can be broken down into what? Hydrogen ion and hydroxyl ion. So this will give us HCO3 minus OH, and this will give you this. Okay, that is how. C, CO2, add one oxygen to it, that will be what? CO3, hydrogen carbon plus H plus. So it is always in this form in your body. Okay, but actually I won't be using that for my explanation. Okay, because we are still gonna get the same product. Okay, so now look at this. We have CO2 reacting with what? Ammonia. So how does that happen? Before CO2 can actually what? React with ammonia, we need what? Energy. we need what? Energy. And the energy is gotten from what? ATP. The energy is gotten from what? ATP. That is to tell you that what? We need two molecules of what? ATP here. In this reaction, we need what? Two molecules of ATP. So we have CO2 reacting with ammonia. CO2 plus ammonia. Okay? Using two molecules of ATP. This will then give us, that is our product. I just want to write the product here, okay? So our product will now be what? We're gonna get this product. Look at it. I'm gonna explain the product, okay? C NH3O and your phosphate group. Okay, now let me explain this to you. This is it. We have CO2 reacting with ammonia using two molecules of ATP. So this is giving us this. And this product is known as what? Carbamoyl phosphate. Yeah, I'm going to explain how we get the product and also explain the meaning of this name. Okay, now, how do you think this product is gotten? Ammonia. This is the ammonia here. CO2. Okay, this CO2. Take this C. This is the C. This two, just take it as this double bond, okay, and put your oxygen on it. Just a trick, mind you, just a trick. The ammonia, this is the ammonia part, okay. This C, the C from CO2, this is the C, okay. These two, the double bond O, and phosphate. I hope you understand it. So, but let's look at the number of bonds that this ammonia is supposed to have. Ammonia is supposed to have how many bonds? 3 bonds. But how many bonds is it having now? 3 from hydrogen and 1 to carbon. It means that what? Ammonia here has what? How many bonds? 4 bonds. Instead of what? Having what? 3 bonds. So the best thing is for me to what? Just remove the 3 and replace it with what? 2. So that's 2 from hydrogen and 1 from the carbon. So ammonia bond is complete. Carbon is supposed to have how many bonds around it? 4 bonds. 1, 2, 1 from the phosphate and 1 from the ammonia. Do you understand it? So this guy is complete. So now let us look at the name. The name is called what? Carb. Okay, that is, we have carbon. From this name, you can also draw the structure. Carb. We have carbon. Ammo from ammonia. Do you understand it? Carb. This is a trick. I'm not saying that this is how they actually name it or this is what they meant by naming it this way. Just a trick. Okay? Carb. The carbon. Ammo. The ammonia part that we added to it. This YL. Don't forget, we have something called what? Carbonyl. If you understand your organic chemistry very well. When we talk about carbonyl, we are talking about a carbon with what? This. Double bond and oxygen on it. When we talk about carbonyl carbon, that is a carbon or carbonyl group. That is a carbon with what? Oxygen on it. So this YL, you know this is carbon. This YL is telling you the type of the carbon. Carbon with what? Oxygen on it. Do you understand it? So this YL here is telling us that what? This our carbon has an oxygen on it. That is from carbonyl. This YL is telling us that what? This is the type of carbon we are talking about, okay? So it should have just been carbyl, I don't know. So we have carbon, we have the carbon here, ammonia. This YL is telling us that what this type of carbon we are talking about is a carbonyl compound, a carbonyl carbon rather, that is a carbon that has oxygen on it from your what? Carbonyl compound. Do you understand? That is a carbon that has what? Oxygen on it. So carbon, I'm trying to draw it. Ammonia. Okay, this YL is telling me that what? It has this. Then phosphate. Add your phosphate group to it. So easy. Do you understand it? So this guy is called what? Carbon, ammonia, YL, telling you that what? it has a carbonyl functional group, that is, it has oxygen. That carbon is what? A carbonyl carbon, then phosphate. So carb amyl phosphate, carb amyl phosphate. I hope we understand that. We understand that, and I'm very sure you understand the structure now. Carb amyl phosphate. So that is that about that. So now this carbamyl phosphate is the product, but don't forget that what a particular enzyme must be here. So what is the name of the enzyme? It is very simple. The enzyme is also known as carbamyl phosphate synthetase. When we say synthesize, it means that what we are producing something. Okay, synthesize means what? Produce something. So the name of the enzyme is what? Carbamyl phosphate synthesis. That is an enzyme that produces, or an enzyme that is involved in the production of what? Carbamyl phosphate. That's why they call it what? Carbamyl phosphate synthetase. But you need to be very careful. We have something called synthetase and synthase. Synthetase. We also have, let me write that with the other marker. So we also have what is known as what? Synthase. Synthase. So how do we differentiate synthase from synthesis? Synthesis means that what? It produces. Synthase also means that what? It produces. Okay, that is, it is involved in the production of a particular stuff. Do you understand it? But what is synthesis? Synthesis is telling you that what this one requires what? ATP. Why synthesis is telling you that what this one does not require ATP. So you don't make that mistake. Because in your question, probably like your MCQ question, you can see, okay, which enzyme is used in this, and at the back of the enzyme they can write what? Synthase. It is not synthase, it is what? Synthetase, because ATP is used. So when ATP is used, you call that enzyme synthetase. Synthetase. If ATP is not involved, you call it what? Synthase. Are we good to go? So the name of the enzyme here is called what? Carbamyl phosphate synthetase. An enzyme that is involved in the production of what? Carbamyl phosphate. So it is called what? Carb, the carbon, ammo, the ammonia, YL, telling you that what? It is a carbonyl functional group, phosphate, synthase. Synthetase 1. Are we good to go? Do you understand this? Let's move to the next thing. Now, the next thing is that what? This carbamyl phosphate will then react with ornithine. It will react with what? Ornithine. You know the structure of ornithine now, right? You know the structure of ornithine. Ornithine is your alanine, then add cone to it. Ornithine is just alanine. Do you know the structure of alanine? Add cone to it without adding the ammonia part, the urea part. You understand it? So that's ornithine. Now the ornithine is going to react with what? This carbamyl phosphate. Now that's to tell you that what? The place that the you know, in the structure of arginine, you draw the alanine cone, then you put the urea there. Okay, so but when you remove the urea, you will have what? Ornithine. So when ornithine reacts with what? Carbamyl phosphate, the place you remove the urea is where you are going to put this what? Carbamyl phosphate. Do you understand it? That bottom, the bottom where you remove the urea, is where you are going to what? Attach this what? Carbamyl phosphate to. Do you understand it? So that's where I am attaching your carbamyl phosphate to. Now let us do that now. So the structure of our ornithine. How does the structure of your ornithine looks like? So ornithine. Oh, I'm sorry. Ornithine, that is NH2. That is our what is it called first? Alanine. HCOOH. CH3, but write it as CH2. You understand? Because we're still gonna remove bonds. So this is our alanine. Then write the cone CH2, another CH2, then end it with what? N. So this is our ornithine. So it is reacting with our what? Carbamoyl phosphate. Okay. Now, when it reacts with what? Carbamoyl phosphate. I hope you can see this. Okay, so it will react with this. So what will happen is that what? This guy will just come here. So it will get attached to this. I hope you can see this. So it will be attached to this. Do you understand that is? This is where we remove the urea part. So this guy is gonna come here and get attached to this bottom. I hope you understand it. So but now be careful. What will happen here is that what? This phosphate needs to what? Drop. So the only guy that will be transported or that is gonna move from here to this side. Yeah, I'm sorry. Please, hello. Please check if this thing out because the thing actually check now. Yeah, thank you. So this phosphate is gonna gone. So the only thing that is coming here is just what? This. Please help me with this board. Just remove it, yeah. Yeah, thank you. So the only thing that is coming now is just this what? NH2, carbon, oxygen. This phosphate is what? Out. Do you understand it? Do you understand it? So this phosphate is out. So where will I stop? So that is NH2. So there is nothing here. So this it is only this guy that will come here because the phosphate is gone now. So you're gonna turn this guy upside down. That is this carbon. This guy will be like this now. The carbon will be like this. Put it here, just rearrangement. Okay, this is just a rearrangement. NH2, so that this guy will be used to what? Attached to this. Okay, so I'm gonna have this carbon O NH2. So this is our product here. So that's to tell you that what this now is gonna have its own name. This guy. So what do we call this guy? We call this guy what? Citrulline. We call this guy what? Citrulline. Citrulline. I hope you understand this. How do we get to citrulline? The first thing is that what? Your CO2 should react with what? Ammonia using what? 2 molecules of ATP to give you what? Carbamoyl phosphate. Okay. Now your carbamoyl phosphate will react with what? Ornithine. And you understand how you got your ornithine? Your ornithine is actually gotten from your arginine by removing the lower part of the arginine, that is the urea part. So the arginine is coming. Your ornithine. You know this is ornithine here. This is ornithine. Yeah. Okay. This is ornithine. This guy from here to here is our ornithine. Okay. Here to here is our ornithine. So it is reacting with the what? Carbamoyl phosphate. Carbamoyl phosphate. So what will happen? The phosphate will drop. So only this guy will come in and it will get attached to our what? Ornithine. So when it attached to your ornithine, everything will then be called what? Citrulline. Citrulline. I hope you understand it now. So citrulline. So now let's move on to the next one. What happened to citrulline? So CO2 plus ammonia plus 2 ATP to give what? Carbamoyl phosphate. your carbamyl phosphate carbamyl phosphate plus your ornithine will give what? Citrulline. Now this also has an enzyme. What is the name of the enzyme? You will notice that what we actually did in the last reaction I showed you was that what we transferred the carbamyl part to what? Ornithine. We did not transfer the whole carbamyl phosphate because we dropped the phosphate. We then transferred the what? The carbamyl part to the what? Ornithine. So it means that what? The name of the enzyme that will be here will be known as what? Trans carbamyl. Trans what? Trans, that is transfer carbamylase, that is an enzyme that transfer what, or that is involved in the transfer of what? Carbamyl. So we call it what? Trans, that is it transfer what? Carbamyl. It transfer carbamyl, but because of the enzyme you just have to put the what? Lase there. Do you understand it? So trans carbamylase. Do you understand it? So, but where does it transfer it to? It transfer it to what? Ornithine. So the full name of the enzyme will be known as what? Ornithine trans carbamylase. That is, this guy transfer carbamyl to where? Ornithine. Do you understand it? Do you understand the name of the enzyme, how it is gotten? It transfer carbamyl. It did not transfer the phosphate side, so it only transferred what? The carbamyl to who? Ornithine. So that is the full name of the enzyme. You just put a list there. So ornithine trans carbamylase. So that is the name of the enzyme that is involved in the reaction between what? The reaction between ornithine and carbamyl phosphate to form citrulline. The name of the enzyme involved is known as what? Ornithine trans carbamylase. The list is just telling you that what it is, an enzyme. So this is the enzyme. So do we understand that? So now the next thing is that what? Our citrulline will then react with what? Aspartic acid. Your citrulline should react with what? Aspartic acid, or you call it aspartate. But I want to use aspartic acid, okay? Do you know why I said you should call it aspartate? Because normally in the body, your aspartic acid will be in form of what? Aspartate. Why do we say that? Because don't forget, it is an acid. Because it is an acid, it's gonna have a lower pH, and the physiological pH of your own body is around 7.4, which is what? Slightly basic. Okay, so being an acid, a good acid should always what? Donate its what? Its proton. So anytime aspartic acid donates its proton, it is known as what? Aspartate. But still, it is still what? An acid. Okay, so having COO minus, you are still gonna get the same thing. This one is just telling you that what? It has given out its hydrogen. So the next thing is for what? Our citrulline. Don't forget, you remember the structure of your ornithine. So when you add carbamyl phosphate to your ornithine, all the carbamyl parts only, rather, you get what? Citrulline. Okay, now the next thing now is for what? For citrulline to react with your aspartate, or you say your aspartic acid. Okay, so it will now react with it. Do you still remember the structure of your aspartic acid? Aspartic acid, the structure is gotten from what? How do you draw the structure of your aspartic acid? Draw your alanine, then put the acidic part. Abi now, aspartic acid, don't forget please. You can always watch our video on how to draw the structure of the 20 amino acid. So aspartic, why did I clean it? Aspartic acid or aspartate. Okay, so we have our citrulline to be Citrulline. How do we draw the structure of citrulline? NH2 carbon, COOH. So this is our alanine. So we're gonna add cone for us to get ornithine. Cone, CH2, CH2, nitrogen. So this is ornithine. So but for us to get citrulline, we need to add what? Carbamyl to it. So and our carbamyl is our this thing without the phosphate anymore. So this is it. You remember the structure of your carbamyl phosphate now, which is you having oxygen, your phosphate group, and NH2. So this is the NH2. NH2. You can also put this NH2 here, put this one here, okay? So do you understand it? So now let's move on. So this is our citrulline. So now citrulline is reacting with what? Aspartic acid plus aspartic acid. Now we have to react our citrulline with what? Aspartic acid. But don't forget that what your aspartic acid, anytime it loses a particular proton, okay, it turns to what? It turns to aspartate. Okay, I hope you are good and I hope you understand that. So how do we draw the structure of our aspartic acid? You draw the structure of your aspartic acid basically by drawing the structure of your alanine first. I mean, we said, you know, in all the amino acid apart from glycine, you need, for you to get their structure, the first thing you need to do is the what? The structure of alanine. Okay, now because this guy is an acid, after the structure of alanine, you then add the what? Acidic functional group. And when we talk about acid in organic chemistry, we are basically talking about what? COOH. This is the acid. So after the structure of your alanine, you draw this to it also. So that is the structure of your what? Aspartic acid. Now I have to react this citrulline with my aspartic acid. So how do we do that? How do we do the structure of aspartic acid? The first thing is what? Alanine, NH2, carbon, hydrogen, COOH, then CH2, which is our alanine. You know your alanine should be CH3, but because I still have to add something to it, that is a bond, so I'll leave it as what? CH2. So now the next thing is to add the acid, which is what? COOH. So this is the aspartic acid. So now what is this aspartic acid doing? This aspartic acid is reacting with what? Citrulline. This is called what? Citrulline. This is what? Aspartic acid. Aspartic acid. Do we understand that? So we are reacting citrulline with aspartic acid. Very simple reaction. So what do you think will happen here? What will happen here is just that this guy here will just come, that is especially this ammonia part, it will just come here, this NH2 part, it will just come down here to this carbon. So what is happening is that what? Everything here will just come down here to this carbon and it will get what? Attached to this bottom. Everything is what? Attaching to the what? To the bottom. You remember that what? Also, you know, from here, from this nitrogen here, this place are marked blue. From this nitrogen here upward is our ornithine. That is our ornithine. And we then added what? The carbamyl part of the carbamyl phosphate. We added the carbamyl part of the carbamyl phosphate to the bottom. Now what we are doing here also is that what? Add this aspartic acid to the bottom of this carbamyl also. That is what we are doing. So we're gonna add this guy, we're gonna bring it here. So but the moment you bring this guy here, this oxygen will what? It will go. Do you understand it? So that is what I'm gonna draw on the board now. So I'm coming. So now what is happening? So our citrulline, N NH2 carbon hydrogen COOH CH2 CH2. Like I want to draw the structure of citrulline. So citrulline, if I want to get the structure of citrulline, I will draw ornithine. So ornithine is what? Alanine and cone. Alanine, then cone. So my cone is CH2 CH2N. So after drawing ornithine, you are putting the what? The carbonyl part. And the carbonyl part is what? Carbon, okay, oxygen and nitrogen. I can actually put the nitrogen in this side, but just because I want to put my aspartic acid in this side, so I can just bring my nitrogen down here. Okay, it's still the same thing. So and don't forget that we said the moment the nitrogen, that is this O aspartic acid, comes in, what will happen to this oxygen? It will go. So this guy is coming here now. Oh, the board, I'm sorry. So this guy, everything here. So everything here is coming here. Do you understand? So everything is coming here. Everything is coming here now. So everything is coming here. Okay. So when it comes here, what do you think will happen? This oxygen leaves. When it comes here, this oxygen what? Then leaves. It means that what? This will turn to what? NH2 carbon hydrogen COOH CH2 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 N C, okay, NH2. Are we good? So the next thing that is coming here is what? So the next thing that is coming here is what? This guy, and it will attach with its what? Nitrogen. So we have, so let me use the black marker for this nitrogen here. So we have the nitrogen in form of NH2 C. This NH2, this is it. This C, this is it. The COOH. Do you understand that? So CH2, and so the next thing is what? CH2 and then COOH. Do you understand this? What is this? This is the what? The ornithine part, okay? The oxygen has been removed and this aspartic acid has been added. You can see this is your aspartic acid. Your aspartic acid is this, okay? This is your aspartic acid. I hope you understand it. Now you will notice that what? This double bond was here before, but the oxygen has left. It means that what? The double bond should be what? Somewhere here. So it means that what? The double bond will be with what? Either this nitrogen or this nitrogen. So we're gonna put the double bond here. I will not put the double bond here because this guy is just coming in. Double bond has been here before. So the moment this oxygen leaves, one of these guys should collect the what? The double bond. That is, they should take the double bond. So because these guys are this guy has been with this carbon before, so it will take the double bond. I hope you understand it. Now you're looking at this structure. What do you see? You will notice that what? From citrulline, reaction between citrulline, that is this citrulline and aspartic acid, it gives us something. It gives us what we know as what? Agenosuccinate. Now the question is that what? Why do you think this guy is called agenosuccinate? Why do we name this guy agenosuccinate? Now I'm gonna show you now, okay? So let me just clean this. I hope you understand what we are doing. So this is what we have. We have this and this. Now, don't forget the structure of your what? Of your arginine. From the structure of your arginine, we have what is known as what? Alanine. Okay, that is where is our the first one of the structure of your arginine is what? Your alanine, which all amino acids should have. So this is the first part is alanine. This one, this side is what? The alanine. Okay, the next one is the cone, right? Cone, CH2 then N, and add the urea part. Don't forget about the urea your urea has what? Two nitrogen with what? One carbon, and that carbon has an oxygen on it. So that is two nitrogen with one carbon. So the carbon has an oxygen on it. This one is having NH2, NH2. Do you understand it? But by the time you want to add this your urea part to your what? To your kun, that is to your ornithine, for it to give you arginine. Don't forget that what? After the cone, you just add the urea part. By the time you want to add this urea part, don't forget that what you said, this oxygen will go. At the beginning of the video, we said is that this oxygen will what? Go. So this is the only part that will be what? Added, and the double bond will have shifted to one of these what? Nitrogen. Okay, so now looking at this thing, you will notice that what? We have NH2 carbon. So we have NH, we have NH. Okay, the moment we add this part, you know, if I want to add this part to this cone, I will have what? NH2 carbon, NH2. Now the oxygen has gone, but the double bond that was here before, we have to be what? Come to one of these what? Nitrogen. So either here or here. So you can put it here. So this nitrogen is supposed to have how many bonds around it? Just 3 bonds. But now it is having how many bonds? 4 bonds. Okay, that means that this one will just be what? NH. You will notice that what? This structure here, NH double bond carbon NH2, is still the same thing as what? NH double bond carbon NH2. That is to tell you that everything here is your what? Arginine. That is breaking this guy here. If I should break this guy here, I can actually what? Get the structure of what? Arginine. Do you understand it? So the moment I break this guy, I'm going to get the structure of what? Arginine. So now let's look at this guy, this remaining guy. Let me draw this remaining guy out. We have carbon, COOH. Okay, we have CH2, we have COOH, we have hydrogen here. Okay, now looking at this structure now, you will notice that what? It looks like one of the things we've explained from the beginning of this video, which is what? The structure of your what? Succinate. We said your succinate will have what? 2 carboxylic. You know, this guy, I can actually what? Straighten it. That is by saying, okay, let me just draw it in another form. This COOH, okay, I can write HOOC. This is it. Then followed by C. Okay, put an H on it, followed by CH2, followed by COOH. Still the same thing. Okay, so that's to tell you that what? This is succinate. Okay, this is our what? Succinate here. So it means that what? This part is what? Succinate. That is why we call this whole structure what? Adenosuccinate. That is, the moment your citrulline reacts with what? Aspartic acid, you get what? Adenosuccinate. Do you understand it? But mind you, don't forget that what? If after breaking this bond here, okay, you know, we've gotten our arginine. Abi now, we've gotten our arginine. Okay, we are not going there now. Sorry. So this is our product now. So this is adenosuccinate. Okay, this is our adenosuccinate. You know, hydrogen is, we are supposed to have an hydrogen here, but we did not have the hydrogen. This bond is used to attach to this what? Arginine part. Okay, I hope you understand that. So we have adenosuccinate. So now, what is the enzyme that is controlling this? You notice that what? A particular thing is formed. That is, citrulline is reacting with what? Aspartic acid to form adenosuccinate. It means that what? The enzyme must be a what? Synthase or synthesis. It means that what? The enzyme involved in this reaction should either be what? A synthase or a synthesis. A synthase, it means that what? No ATP is required. Why? But if it is a synthesis, it means that what? ATP is what? Required. And in this reaction, ATP is what? Required. So it means that what? The enzyme that is controlling this thing, we have what? Synthesis. So what synthesis, what an enzyme? So you see that what the enzyme here will be what? Adenosine synthetase. That is an enzyme which is involved in the formation in the formation of what? Adenosine. That is why we call it what? Adenosine synthetase. Why the synthetase? Because of the what? ATP. That is, this reaction requires what? Energy. It needs a boost. It needs a boost. Okay. So now the next thing is for what? This adenosine to break. Do you understand? And you know what is going to break too? So this guy is going to break here in the middle. So when it breaks, it will break into what? Adenine and what? Succinate. But don't mind you, the moment this guy breaks here, when it breaks, you know, this carbon will not have any bond around it again. That is, you've removed, yes, that is, you've removed one bond from this carbon here. Because of that, this carbon here is going to form what? A double bond. It means that what? Your succinate here will turn to what? Fumarate. Because we said that what? Fumarate is the one that we have what? A double bond in between. I hope you understand that. So let me draw the structure and you see. So you want to draw the adenosine. So adenine and succinate. NH2 C COOH. Hydrogen is here. This one is what is here? Your alanine. So we've completed the structure of our alanine. Cool. CH2 CH2N. So we have carbon. We also have NH here. We have NH, okay, and we have, because this carbon is supposed to have three bonds, so one bond from here, one bond from hydrogen, and one bond from succinate. Just let me write. I can actually write the hydrogen here so that you can see it. That is, the next one is succinate, okay. Carbon, COOH, abi, carbon, which is CH2, COOH. So don't get it confused. If it were NH3 before, NH2 before, just check the bond and just balance it. Are you with me? I hope you understand that. So, but my bad. Let me use my blue marker to draw this. So NH. Let me just put it at the top so that you will see the bond. NH. C COOH and what? CH2COOH. So this is the structure of what? Adenosine. Okay. So now the next thing that is happening here is what? For us to what? Break these two guys. That is, we need to separate them. You've already seen that. Okay. This thing is that if I can take this NH to be part of this whole group that is on your, okay, don't let me see on your left or right because I don't know how it is going to show here. So if I can take these guys together like this will give us the structure of what? Adenine. Do you understand? So I'm going to break this guy here. So why the remaining guy here will be what? Succinate. That is why it is named adenosine. How do you know it is succinate? Because it has 4 carbons, 1, 2, 3, 4, and out of the 4 carbons we have 2 carboxylic acid group there, which is this one and this one. Do you understand it? And also there is no double bond here. That is why it is not fumarate. Okay, so it is what? Succinate here. Okay. Now the next thing is that let us break this thing. So how do we break this bond? How do we break it? We just break it here, okay, so that we can get our adenine structure. So we break it here. We break them here. So we are going to have adenine and succinate. Okay, so we are going to get adenine and succinate. Now the question is that what? Which enzyme is involved in the what? In the breakage of adenosine into what? Adenine and succinate. The name of the enzyme is what? Lyase. That is lysis. When we say lysis, lysis means what? Breaking. Lysis means what? Breaking. So the name of this enzyme is known as what? Adenosine lyase. That is an enzyme that breaks adenosine. That is why we call it what? Adenosine lyase. Okay, that is, it breaks adenosine into what? Adenine and succinate. Do we understand it? Do we understand it? So it breaks down the structure. So don't forget this one has an hydrogen on it, because carbon is supposed to have 4 bonds around it. So 1, 2, 3, 4. Now after breaking it, we have our adenine. But let's look at this guy. After breaking the structure, so we will just have this C. Okay, let me use the blue marker for this. Succinate. So I will have COOH. Okay, hydrogen. Yeah, this bond means that what? It is using this one to bond with what? This adenine. Abi now? CH2 COOH. Mind you, this guy was bonding with what? Adenine with this what bond before, but now the adenine has been what? Removed. So what do you think will happen? The adenine has been what? Removed. So what will happen here? Now the next thing that will happen is that okay, what will happen is that this bond, don't forget your organic chemistry, your alkane and alkyne. If I have something like carbon, okay, if I have something like carbon, and I have hydrogen here, I have CH3 here, I have CH3 here. If I should remove this hydrogen, what do you think will happen? Double bond will be what? Formed here. That is, if I should remove the hydrogen that was there before, double bond will be what? Formed here. The same way, because we removed the adenine part, it means that what? This guy will then form a double bond here. I hope you understand it. So double bond will be formed here like that, and a 4 carbon compound, that is 1, 2, 3, 4, that has 2 carboxylic acid, this and this, with a double bond, is known as what? Fumarate. Don't forget to say this at the beginning of the video. It is known as what? Fumarate. We can actually straighten this guy by bringing this CH3 COOH at the top. Okay, you will see the fumarate. So it means that what? When you break adenosine, you are going to get what? Adenine and fumarate. So fumarate is going to what? Go out. That is going into the what? The TCA cycle. I hope you understand that. So when you break this, you break adenosine, you are going to get the adenine and what? Fumarate, because this one is going to form a double bond. I hope you understand it. Now the next thing is our what? Adenine. Let us bring out our urea from adenine. Thank you. Now looking at this, what do you think we should do, or how do you think we should get our urea from adenine? And don't forget the enzyme that is breaking adenosine. Don't forget that what? The name of the enzyme is what? Adenosine lyase. The one that is forming adenosine lyase is, the one that is forming adenosine is known as what? Adenosine, what is it called? Synthetase. Okay. So now let's look at, okay, the structure. Or we have the structure. Oh, I shouldn't have cleaned this actually. So now the next thing is for us to get what? Our urea from our what? Adenine. The next thing is to get our urea from adenine. So now let's draw the structure of our adenine. From this marker is gone. So NH2 carbon hydrogen COOH. Now complete the structure of your alanine. Then cone CH2CH2N. Then add the urea part, that is the structure of your adenine. C NH NH2. So now the next thing for you to do here is just what? Add your urea part to it. That is let us remove this urea part. So how do you think we can remove this urea part? You know that what, from here, this is the only thing we want to remove, okay? So that means that what we need to what? We also need to break this guy. That is, we need to what? Break it. But what type of enzyme are we using here? We are using an enzyme that uses what? Water. Why do you think we need water? Because don't forget that what? For us to get urea, we have this, okay? But it remains one thing that we need. We need oxygen. Because our urea should have what? Our urea should have a double bond here and oxygen. So how can we get oxygen? We can only get oxygen from water. Your oxygen is not just free in your body like that. Do you understand? It is probably like in form of hydroxyl, water or so. So it means that what we need to what? Bring in water into this reaction. Okay? So by adding water to it, OH can what? Come, just look at this. If I have water, this blue marker is gone, sorry. So if I have water, H2O, it can be broken down into what? Hydrogen ion and hydroxyl ion. So now I cannot just get my oxygen directly. Most time you don't just get your oxygen directly. So now when water breaks this guy down, so we can just say that what? Hydroxyl will come here. So by the time hydroxyl attached to this one, you can deprotonate, that is remove the hydrogen. Do you understand? Remove this part. Let's assume this part is out now. So this is all we have now. This one is not there anymore. So let's say this guy is not there anymore. So we need oxygen to be added to this guy. So if this guy comes in form of OH, so OH will be attached here. Then you can then deprotonate. Mind you, it is an enzyme that is controlling all this. Okay? So you need to deprotonate. So when you deprotonate, you remove the oxygen. That means you remove hydrogen. When we say proton is still hydrogen. Okay? Proton is what? An hydrogen without an electron. So when OH comes, you then remove the H. That is all. The remaining H should come here. That is NH2. You understand what I did now? I removed this part. So I have NH2 carbon, NH. Okay, the next thing for you to just do is what? Put an OH here. Okay, OH. Okay, then you remove the H, that is you deprotonate. So when you remove the H, what will happen? Double bond will be formed here. So we have NH2 if we have double bond here. You know double bond is there initially before NH, but because another double bond has been formed, here, the double bond here will what? Is going to go. So the electron will be what? Passed here. Okay, so this one is going to take one more hydrogen like that. So the double bond is not here anymore like that. So we have NH2. That is all. Just for it to be what? Very easy. Just add your OH here. Our oxygen is here already now. So we have NH2, and our O. Do you understand how we got this? We form a double bond here. We formed a double bond here, right? So the double bond that is here needs to go, because this carbon needs what? How many bonds around this? Just 4 bonds, okay? But if I should leave the other double bond, that would be what? 5 bonds, okay? So the best thing is that what? The double bond that is here should what? Go. Okay, that is, the bond should be shifted into this what? Nitrogen. The moment the bond is shifted into the nitrogen, that is, electron is shifted into the what? Nitrogen. This nitrogen will then take a what? A proton. I'm not sure if you understand it. A double bond was here before. Okay, now we've already formed another double bond here. So this double bond is going to shift the double bond that is here. It will shift one of the bond into this what? Nitrogen. So this nitrogen is going to have an electron. Okay, so we use that electron to what? To attract a proton. Do you understand it? So you know it was NH before. Now it will attract a proton. So it will now be what? NH2. So we've gotten the structure of what? Of our urea. Do you understand it? From your, now let me take it again. This is the structure of your arginine. So this part, water is going to like come in. So we are going to use water to break this part. The OH will come here. When the OH is here, you remove this hydrogen, that is, you remove this proton. The moment you remove this proton from hydrogen, from this oxygen, double bond will be formed here, right? So the moment the double bond is formed, this carbon is going to have how many bonds around it? 5 bonds. So what will now happen? This double bond is going to shift the double bond that was there before. It will shift it into the what? Nitrogen. It means that what? Nitrogen is going to have what? Electrons. Okay, so it will use that electrons to what? To attract a proton. You know, a proton does not have an electron. A proton is an hydrogen without electron. So it will use the electron to what? To attract the what? Proton to itself. So it will not be what? NH2. It was NH before. It will not turn to what? NH, because a bond has been shifted into the nitrogen, and it has used that electron to what? To attract a proton. Now, okay, now it is now what? NH2. This one is now O, the double bond O. So this is what? Our urea. Do you understand it? And the product we are going to get back here is what? Ornithine. Don't forget ornithine. So this ornithine will then go back and react with our what? Carbamoyl phosphate. That's how the cycle what? Continues. Thank you.